Okay, follow to the next week. Last week, sorry. From last week that we are talking about the third type of differential equation that we call exact equation. And then I already teach you guys how to prove that whether this equation is exact equation, right? The way that you do, basically, you just present your differential equation in this form: mxy dx plus mxy dy equal to 0, right? And then you're going to define this equation to be exact equation whenever the differential of m respect to y equal to the differential of n respect to x, right? If it is follow this meaning, that means this equation is called exact equation. And we did it last time. And I think a lot of you can distinguish between exact and non-exact equation now. So the next step is the way to find the solution of an exact equation. I just wrote it in a simple way. We have two ways to do it. The first one, you can set either df by dx equal to m or df by dy equal to n. Either one, okay? Either one of these. Just pick one. And then from this, if you do integral of this term, you would get fxy equal to the integral term of m dx plus dy, right? If you do integral, but you will not really know what dy is, okay? And then what you can do is that do the integral of this term. I would say this is called fy. Okay, when you integral this term, you would get something like this. But you don't really know what is hx. But hx will appear in this term, and dy will appear in this term. So that's why I said after you got fx and fy, you got to do union. Do you know the meaning of union? It's from that, like, you pick up, like, for example, if you have set of this number 1, 2, 3, 4, 5, and another set is 2, 4, 6, 8. S1 union to S2, it is equal to 1, 2, 3, 4, 5, 6, 8. No 7, because we have no 7 right here. So that means if you see any number that is in both S1 and S2, you got to pick only one time. But if any number that is not shown in 2 but shown in 1, you take it. Okay? And also the one that not in S1, you pick it. Any number that appear in both S1 and S2, you pick up only one time. Okay, so you get something like this. This is exactly the same. Like you would have function that shown in both fx and fy. Then you got to pick only one. Okay, from this you would get the final fxy, and then the answer of this exact equation would be fxy equal to c, where c is a constant. Okay, if anyone feel uncomfortable with this method, then another method. Again, with this one, you can start from df by dx equal to m or df by dy equal to m, either one. Okay? You pick up, in this case, I just pick up the first one, df by dx equal to m. I do integral, I will get this term. This term you've got to write it as a gy because you don't know what is gy. Okay? And then you do partial derivative of this one by y. Okay? Whenever you do by y, I'm sorry, this is n. Okay? You would make it equal to df by dn, which is the n up here. And then by that you can integral and get term of gy, and then you would end up with the final answer that fxy equal to c. The thing is that doing both ways you will get the same answer. Okay? Still confused, right? Because the way itself is quite complicated, but let me show you the example. It will make you more clear than, just reading the theory. Okay? The first example is just finding the solution of this equation. Of course, it's got to be exact equation because we are trying to solve the answer or the exact differential equation, right? So the first thing that I do is just check out whether this equation is exact equation. So from this m dx plus n dy equal to 0, no matter what, if we want to start with this technique, we have got to rearrange the equation to get this form. Okay, sometimes the differential equation itself come in this term. If it is coming this way, you've got to arrange it to be this way. Okay, you've got to make it to be m dx plus n dy equal to 0. Now m is equal to 1 plus exponential of x times y plus x times exponential of x times y. And n is equal to x times of exponential of x plus 2. So to prove that whether this is the exact equation, you've got to do derivative of m to y and derivative of m to y and n to x, right? You've got to do derivative of m to y and do derivative of n to x. If these two equal, then we can conclude that it is an exact equation. When you do derivative of m to y, x is a constant. So in this case, if you do differential of this, 1 d1 by dy equal to 0. Derivative of exponential of x times y by y equal to exponential of x, right? Because, like I said, if you do derivative of m compared to y, then you would take x as a constant. Any term, any function of x, you look at it as a constant. So in this case, you do d e to put exponential of x to y by dy. If you look at x as the constant, then you can take e exponential of x out of the differential term. That's why you get exponential of x. That is the first term there. And again, the second term, you have the derivative of x times to the exponential of x times 2y by dy. Again, because you do derivative compared to y, you look at x as a constant. So term x times exponential of x, you can take it out from the derivative sign. So you would get x times exponential of x, which is this term, right? So the derivative of m by y is equal to exponential of x plus x times exponential of x. Now, take a look at n. You do derivative of n to x. This one you've got no y, that's a good sign. But the thing is that you've got to do derivative of two functions which is multiplied to each other. So you've got to use that formula. From this, dx e to the power x, exponential of x by x. You would get f dE exponential of x by dx plus e exponential of x dx by dx. Okay? So, the first term you would get what? Differential of exponential of x is equal to exponential of x dx, right? Do you know this? Do you know this? Which is equal to e exponential of x. It's too many formulas that you guys got to review from the calculus. Let me put it this way. If u and v is a function, derivative of uv is equal to v du plus u dv. Again, if u and v is a function, derivative of u over v is equal to these are things that you should know. Okay, this is the formula that you should know before you come to this class. Okay, so that's why I got this. Because if x is u and exponential of x is v, derivative of uv is equal to u dv plus v du. Okay, so that is why it's coming this way. And the derivative of the exponential of x is equal to exponential of x. So that's why when we do derivative of n by x is equal to x times exponential of x plus exponential of x. And then if you look at this, both of them are equal, so that's why this is an exact equation. Now, the way to find the answer of this, when I look at m and n, I know that df by dy equal to n and df by dx equal to n. This is what we know from the first time that we are talking about the exact equation, right? first time that we are talking about the exact equation, I just give you the definition of this. Okay? Now, if we want to find this f, the way that we do is just put dy to the same side as n. Okay, and this is the fxy, but we write it with the curve one because now you have two variable parameters, which is x and y. So we do partial derivative of it. Okay. Anytime that you do derivative f compared to y, you look at x as a constant. And any time that you do derivative of f compared to x, you take y as a constant. So if you do integral of each term, you wouldn't get the whole function of f. The idea is coming this way. So I'll do the second technique that we told, that I already showed you the way, okay, with this problem. Now, we got to figure it out which one that's more easier for us to do integral. If we pick up this one, m is m is 1 plus exponential of y plus x times exponential of x times y. So if we pick up this one, then it's going to be hard for us to do integral, right? Because we do integral with x. This one we got to do by part. It's difficult. So I just pick up y first. I try to find fxy from this term first because when I look at it, it's easy. So I use this definition, df by dy equal to n. So if I want to find fxy, the way is just that put dy with n. So I would get n dy, and then I put integral to both sides. I get f equal to integral n dy. And now my n is equal to x times exponential of x plus 2. Whenever you do integral with y, you look at x as a constant. Okay, when x is a constant, you can take x out of the integral sign. So inside you would get integral dy, you would get this one, you would get x e exponential of x integral dy plus 2 integral dy. Okay, and from that, integral dy equal to y. That's why we get x times exponential of x times y. And this one, integral dy also equal to y. So I would get plus 2y. And then I'm supposed to get function of x. So I just put it there as an hx. Okay? And I don't know what is this hx, but it's got to be function which is depends on x only. Because when you divide, you would get 0. Right? If you divide compared to y, if you do derivative of this term compared to y, you would get 0. So that's why it won't show in n. But it's got to have the term of x there. Okay? And then, now, if this is my f, then I would do derivative of f compared to x. Because I want to find this hx. Okay? Now, I do derivative this one compared to x, I would get the first one, when you do the derivative of x compared to x, you look at y as a constant. So I take y out. And then derivative of x times exponential of x equal to x times exponential of x plus exponential of x. Okay, and then the derivative of 2y by dx equal to 0, right? Which is this term. And derivative of x compared to x is this term. Okay, this one equal to what? Equal to m, right? dx by dx equal to m, right? And our m is equal to 1 plus exponential of x times y plus x times exponential of x times y. So just put this one in here. And then this term and this term is to look pretty much the same as this term and this term, so they all cancel out. So at the end, I would get the derivative of hx 2x equal to 1. Right? And from this, I can find hx by moving dx to this side, and to integral for both, I would get hx equal to x. So now the answer is fxy equal to x is exponential of x times y plus 2y plus hx. And now we know what is hx. Hx equal to x, right there. Now we know fxy. The answer of the differential equation is fxy equal to c. Okay, so the final answer is this. That is the first one. The first method that we can use instead of using the union thing. And then I'll show you the second method that we do the union. We do fx, we find fx and we find fy, and then we union them together, then we get fxy.